Today we shall discuss the principles of insulation coordination on high voltage and extra high voltage power system. Why we need insulation coordination? Insulation coordination, that too in high voltage. Electric power supply should ensure reliability and continuity to the utility concern. Nowadays, the main problem is reliability and continuity. You can observe in a home, or you can observe nowadays there will be a not power supply will be not a continuity. Okay, from 24 hours it will not be there. Okay, sometimes they will cut, they will power cut. Okay, sometimes for half an hour or 1 hour. Okay. Mm, 24 hours they cannot give the continuity supply to the consumers. Okay, and also reliability. Okay, nowadays there are many research is papers, research is going on reliability and quality issues and continuity supply to the consumers. Okay, the power lines and substations are to be operated and protected against overvoltage such that the number of failures are as few as possible. Okay, when the power lines and substations are to be operated, if it is protected against overvoltage, then the number of failures will be reduced. Okay, as few as possible. And at the same time, the cost involved in the design, installation, and operation of the protective devices should not be too high. Okay, they are saying that if we are investing for protection purpose, that should the design and installation and operation of that protective device should not be a more cost or should not be a low cost. It should be medium. Okay, it should be reasonable cost. Hence, a gradation of a system insulation and protective devices device operation is to be followed, keeping in view the importance of the various equipment involved. While we consider the insulation and also protective device operation, we should give the main importance of various equipment. What are the equipments we are using, and what type of protective devices we should use, and how we should save the cost, and it should be reasonable and it should protect the device. Okay, these are the main points for uh, that is insulation and protective device operation. Okay, next, substations contain transformers, switchgear, and other valuable equipment with non-self-restoring insulation coordination in high voltage, which have to be protected against failures and internal destructions. They are saying that you already know about a substation. Okay, because you already went for substation, you already gone for that is a internship. Okay, so you'll know about the substation, how the substation will be, and what are the equipments they use, and what are the protective device they use, and how they are maintaining that. Okay, if any fault occurs, how it will react. Okay, relays, and what are how protective device will react, and how the internal disturbance or destructions will happen. Okay, next, for other apparatus which contain self-restoring insulation, like a string insulator, they may be allowed to flash over in air. Okay, that is self-restoring insulation. Okay, self-restoring insulation means if any minor fault occurs, it will only restore the insulation. Okay, like string insulators, you already know about the insulators. There are pin type insulator, string insulator, and shackle insulator. We have used for different voltage level and for different purpose. Okay, the main purpose insulator is to protect the conductor and protect the devices. Okay, they may be allowed to flash over in air. It will allow the flash over in air, but the flashover should be kept to minimum so that the system disturbances are the least. Lightning and switching surge protection requires establishment of establishment of this is it, but the flashover should be kept to minimum so that the system disturbance at the least. Lightning and switching surge protection requires establishment of protective voltage levels called shunt protection levels. Okay. Next, the lighting impulse withstand level known as the basic impulse level. That's in that lightning impulse withstand level known as the basic impulse level. It is established for each system nominal voltage for different apparatus, whereas equipment and other component parts should have their bill nothing but basic impulse level, okay, above the system protective level by a suitable margin. This margin is usually determined how it is determined if with respect to air insulation by statistical methods. For non self restoring insulation coordination in high voltage like the transformer insulation, the margin limit is fixed using conventional method. For system voltage below 400 kV, the switching surges are not of importance. If the BIL is chosen correctly relative to the prevailing protective level, the equipment will have an adequate switching surge level. For high voltage system, for system voltages, since the switching surges are of higher magnitude compared to the lightning over voltages, switching surge magnitude are more important and the following criterion is to be adopted. That is, first criteria is the flashover voltage of a protective derived is chosen such that it will not operate for switching over voltage and other power frequency and its harmonic over voltages. But other long duration over voltages, namely sustained voltages due to faults and even the above mentioned over voltages, may sometimes cause thermal overloading due to the leakage. So BIL has to be higher. Okay, they are saying that BIL has to be higher. Why? Because the flashover voltage of protective derive is chosen that it will not operate for switching over voltage and also for other frequency, power frequency, and also harmonic over voltages. Next, for EHV system, it may be economical to use protective device for limiting the over voltages due to lightning as well as switching surges to a particular level. In extra high voltage system, it is economical. Okay, a protective device for limiting the over voltage due to lightning and switching surges. There are such arresters. What does it do? It will operate for both types of over voltages. Okay, that is both type of over voltages. Maybe it is due to lightning and switching surges. Okay, in such cases, it is preferable to assign to each protective equipment a switching impulse level, that is SIL, so that there is a small margin above the controlled switching surge level, so that the surge diverters operate on switching surges only when the control devices fail. They are saying that there is a small margin above the control switching surge level, so that what happens, so that surge diverters will operate on switching surges only when the control devices fails. Okay, if any control devices fail, then only surge diverters will operate. Okay. Only rod gaps and lightning arresters are used as a protective devices for protection, and their characteristics are considered here. The ideal requirement of a protective device connected in parallel or in shunt are: first is it should not usually flash over for power frequency over voltage, and the old time characteristics of the device must lie below the withstand voltage of the protected apparatus or insulation. The marginal difference between the above two should be adequate to allow for the effects of distance, polarity, atmospheric conditions, changes in the characteristics of the devices due to aging, etc. It should be capable of discharging high energies contained in such, and also recover insulation strength quickly. Whatever the equipment you consider for that, insulation and the protection devices are required. Okay, it should not usually flash over for power frequency voltage. These are what are these points? These points are ideal requirement of a protective devices which we connect in a parallel. Okay, and the equipment we connect in parallel, these requirements should be there. Okay, it should not usually flash over for what? It should not flash over for frequency voltages over voltages, and the voltage time characteristics of the device must lie below withstand voltage of the protected apparatus or insulation, and the marginal difference between the two above two should be adequate to allow for the effects of distance, polarity, atmospheric conditions, and changes in the characteristics of the device due to aging. Next, it should be capable of discharging high energies contained in surges and recover insulation strength quickly. It should not allow power frequency follow on current to flow. These are the requirement for what? Requirement of protective device which is connected in parallel. Okay. Next, the behavior of shunt connected protective devices, that is like rod gaps and surge diverters, along with the transformer insulation coordination in high voltage, that is given by this is a figure for that. Old time characteristics of a transformer, rod gaps, and surge diverters. One is a steep fronted lightning surge, and two is a slow fronted lightning surge, and three is a fast switching surge, and four is a switching surge, slow switching surge, five is a power frequency, that is 1 minute withstand voltage. And in figure B, transformer A is a transformer, and B and C are the rod gaps, and D is a surge diverter. X is a critical slope. The transformer insulation strength is given as old time characteristics. The relative insulation strength of the transformer curve A, rod gap curve B and C, and the lightning arrestor, that is curve D. A lightning arrestor. What does lightning arrestor do? Lightning arrestor will protect the transformer insulation in the entire time region. The rod gap. What does rod gap protect? The rod gap protect the transformer insulation only if the rate of rise of surge is less than the critical slope. Okay. A rod gap also used for to protect the transformer insulation, and lightning arrestor also used to protect the transformer insulation, but lightning arrestor protect the transformer insulation in the entire region. Okay, this is the difference. Lightning arrestor will protect the entire time region, and the what does rod gap protect? In rod gap will protect the transformer insulation only, that is that it have a condition, that is only if the rate of rise of surge is less than the critical slope, then only it will protect, and then only it will act. If the surge voltage rise is as shown by curve 1, rod gap flashes and protects the transformer. If the surge voltage rise follows curve 2, that is, you can observe if it follows to the curve 2, then only the surge diverter can protect the transformer insulation. They are saying that if the surge voltage rise is shown by one curve 1, that is rod gap flashes and protects the transformer. If that is the condition, then rod gap will protect it. If the surge voltage rise follows curve 2, then surge diverter can protect the transformer insulation. Next, rod gaps are simple and cheap devices but do not meet all the requirements of a protective devices. It is a less cost, and if you use that, we cannot meet the all the requirements of protective device. They over, so we go for the flashover characteristics will depend on the atmosphere conditions, polarity of the wave, and wave shape also. It may give rise to very steep impulse waves on the transformer windings as chopped waves because no current limiting resistance is used. Chopped impulse waves may lead to the destruction of the transformer turn-to-turn insulation coordination in high voltage. But still, rod gaps provide reasonable protection where lightning surge levels are low and steep fronted surges are controlled by overhead ground wires. Next is a selection of surge arrestor. How we select the surge arrestor? There are no nonlinear resistors in series with the spark gap, which acts as a fast switches. A selection of surge arrestor or lightning arrestor. You can see this figure. Okay, this is a figure non-linear element surge arrestor. One is a line end connector, and 2 is a porcelain housing, and 3 is a series gaps, and 4 is a nonlinear resistor element blocks, and 5 is a ground connection, and 6 is a spring, and 7 is a base, and 8 is a watertight sealing. A number of nonlinear resistors elements made of silicon carbide are stacked one over the other into 2 or 3 sections. They are usually separated by spark gap. The entire assembly is housed in a porcelain watertight housing. The volt ampere characteristics of a resistance element is of the form that is I is equal to K into V to the power of A. I is a discharge current and V is applied voltage across the element, and K and A are the constants depending on the material and dimension of the element. When a surge voltage, that is Vi, is applied to the surge arrestor, it breaks down the giving the discharge current ID and maintain a voltage Vd across it. It provides a protection to the apparatus to be protected and above the protective level VP, that is VP. The lighter designs operate for smaller duration of currents, while the heavy duty selection of surge arrestor with assisted or active gaps are designed for high current and long duration surges. The lighter design is used for small duration of current, and heavy duty selection of surge arrestor with assisted or active gaps are designed for high current and long duration surges. The lighter design arrestor can interrupt 100 to 300 amps of power frequency, follow on current, and about 5000 amps of surge currents. If the current is to be more and has to be exceeded, the number of series elements has to be increased, or some other method to limit the current has to be used. Okay. These are the points we need to remember for selection of surge resistor. First is we need to remember this one. Okay, they are saying that why we use non-linear resistors in series with the spark gaps, which will act as a fast switches. Okay, this is the first. And next is a number of non-linear resistor elements. Why we use it is a made of silicon carbide, and carbide are stacked one over the other into 2 or 3 sections. and they are usually separated by spark gaps. The entire assembly is housed in a porcelain watertight housing. Next is high is equal to k into v to the power of a, and what is high and what is v you should know. K and a are the constants depending on what? Depending on the material and dimension of the element. Next is you need to know that when we apply vi, okay, that is a surge voltage, then surge arrestor it will break down giving the discharge current and maintain voltage across it. It will provide a protection to the apparatus which we are connected to protect the apparatus to be protected above the protective level. And these 2 points, the lighter the design operate for smaller duration, and the heavy duty, that is high currents. Okay, if it is a lighter design, it will operate for smaller duration of current. If it is a heavy or more, then it will operate for long duration. That is heavy duty selection of surge arrestor that will operate for high current, and it will operate for long duration. The lighter design arrestor can interact 100 to 300. And what about this heavy duty will operate? It will operate more, okay, more than lighter design arresters. Next, in heavy duty arresters, the gaps are so arranged that are burns in the magnetic field of the coils excited by power frequency follow-on currents. During lightning discharge, a high voltage is induced in the coil by the steep front of the surge, and sparking occurs in axillary gap. They are saying that during this lightning discharge, what happens? A high voltage is induced in the coil by the steep front of the surge, and sparking occurs in the auxiliary gap. For power frequency follow-on currents, the auxiliary gap is extinguished as a sufficient voltage will not be present across the auxiliary gap to maintain an arc. Okay, sufficient voltage will not be present across the auxiliary gap for what? To maintain an arc. The main gap arc occurs in the magnetic field of the coil. The magnetic field, aided by the on-shaped main gap electrodes, elongates the arc and quenches it rapidly. The follow-on current is limited by the voltage drop across the arc and the resistance element. During such discharge, the lightning protective level becomes low. Sometimes it is possible to limit the power frequency and other overvoltages after a certain number of cycles using a selection of surge arrestor. The permissible voltage and duration depend on the thermal capacity of the arrestor. The way to limit the power frequency and other overvoltages after certain cycles, okay, after for a few minutes or after a few seconds, we can limit the power frequency and also over voltages by using what? By using selection of surge arrestor. Next, the permissible voltage and duration depend on the thermal capacity of the arrestor. The weighted arrestor voltage is normally chosen so that it is not less than the power frequency over voltage expected at the point of installation under any fault or abnormal operating condition. They are saying that the weighted arrestor voltage is normally chosen that it is not less than the power frequency over voltages expected. Okay, that is line to ground at the point of what? At the point of installation, we should know that it should not be less than the power frequency over voltage. Okay, while installing only, we should note that it should not be less than. If any fault are abnormal operating conditions, okay, voltage is normally chosen, sir, so that it is not less than that power frequency over voltage expected that point of installation expected at the point of installation under any fault or abnormal operating condition. We should know before if any fault occurs, how much voltage rise will be, how much over voltage will occur. Depending on that only, we should select the voltage arrestor or surge arrestor. Characteristics of a surge arrestor. These are the characteristics of a surge arrestor. Typical characteristics of a selection of a surge arrestor in the voltage range, that is 100 to 200 kV and 10 kiloamps, that is heavy duty type. This is the table for characteristics of 100 to 200 kV surge arrestor, 10 kiloamps and heavy duty type. Next is the surge arrestor for extra high voltage system. The selection of surge arrestor voltage rating of EHV and UHV system depends on the rate of rise of voltage, type of system to be handled, whether effectively or grounded through an impedance, etc. Operating characteristics of the arrestor. The usual type of surge arrestor used for the above purpose are, that is, first is silicon carbide arrestor with spark gap, silicon carbide arrestor with current limiting gap, and gapless metal oxide, that is zinc oxide arrestors. The first two types of arrestor have a VI characteristics of the nature, that is V is equal to A into I to the power of N. N varies from 0.2 to 0.6 for the elements. The time to spark for the first type of arrestor is about 1 to 2 microseconds, and the voltage is limited to 2 pu of the power frequency voltage. The next is the VI characteristics of the arrestor with the no spark gap. That is, with the no spark gap are not enough to limit the power frequency follow on current, while the arrestor with spark gap provided will have a high limiting voltage. Which don't have spark gap, they are not enough to limit the power frequency, and while the arrestor with the spark gap provided will have a high limiting voltage. Arrestors with the spark gaps are not very well suited to limit the switching over voltages. Arrestors with spark gaps are not suited to limit the switching over voltages. The recent developments in solid state technology have led to the development of metal oxide nonlinear resistors. With the use of these materials, the new class of selection of surge arrestor that can handle very small to very large current with almost constant voltage across them have been developed. One such arrestor is the zinc oxide arrestor, which uses a base material of zinc oxide that is sintered into a different insulating media such as BiO3. The Vi characteristics of such unities is the form V proportional to I to the power of N, where N is equal to 0.02 to 0.03. The Vi characteristics of silicon carbide and zinc oxide arrestor are, this is the figure, typical Vi characteristics of silicon carbide and zinc oxide surge diverters. The advantages of zinc oxide arrestor for extra high voltage system are they are simple in construction, they have flat VI characteristics over wide current range, and you can observe there is a zinc oxide. The absence of spark gap that produces steep voltage gradients when sparking occurs. The main disadvantage of zinc oxide arrestor is that continuous flow of power frequency current and the consequent power loss also. Voltage grading system is not needed for the each of the units of zinc oxide arrestor used in the extra high voltage system. A typical 400 kV line arrestor may be rated at 1.5 kA and may have a resistance of 100 ohms at the peak current rating. Next is a protection of lines with the surge arrestor. Surges are devices that provide low resistance path for overvoltage through an alternate ground path. Their operating characteristics and application is of more importance. The spark gap inside the arrestor acts as a fast-acting switch, while non-linear arrestor elements provide the low-impedance ground path. The arrestor voltage at each terminal when connected to a line surge impedance, that is, it is given as V is equal to 2 open bracket R plus R close bracket divided by R plus Z close bracket U of T, where Z is the line surge impedance and R is the resistance of the nonlinear element, and small r is the ground to earth resistance, and U of T is the surge voltages. This is the Thevenin's equivalent circuit for the arrestor, equivalent circuit of a surge arrestor. When the switch S is open for voltage less than spark over voltage of the surge arrestor Vs, that is, while it is closed for voltage magnitude greater than Vs. The closing of switch is represented by injecting a voltage cancellation wave have a negative amplitude equal to the potential difference between the voltage that appears when the switch is open circuit. Okay, the closing of the switch, you can observe the closing of the switch is represented by injecting a voltage cancellation wave having a negative amplitude. It is a injected voltage cancellation wave. It have a negative amplitude equal to the potential difference between the voltage that appears when the switch is open circuit. Okay, it is almost equal to the VOC. VOC voltage is almost equal to the, when it is switch closed also, it is voltage will be same. Okay, and the voltage developed across the impedance of the device after the switch is closed, ZTH, is the impedance of the system viewed from the terminals of the protective devices. Okay, this ends the fourth module, protection of lines with the surge arrestor. Just to go through the main points, okay, and note down that points and read well for the exams. Okay.